A gas occupies 30.0 dm cube at STP, that is saturated temperature and pressure. What volume would it occupy at 91 degrees Celsius and 380 millimeter mercury? Solution. To solve this question, we will be making use of the general gas equation, which is derived from the general gas law, that says that if a fixed mass of gas under any set of conditions of volume, pressure, and temperature, the value of PV over T must remain constant. That is, PV over T equals K, where K is a constant. P is the pressure of the gas, V is the volume, while T is the temperature. Now, we are being given the initial volume of the gases, that's the initial volume and the initial pressure, as well as the temperature at STP, which is 760 millimeter mercury. That is, the pressure of a gas at STP is 760 millimeter mercury, while the temperature of a gas at STP is 0 degrees Celsius. So we are now asked to calculate the volume at a given temperature and pressure. So here we'll be making this equation to be P1 V1 over T1 to be equal to P2 V2 over T2. So after writing out the formula, the next thing to do is to write out the value given from the question. So from the question, we have our P1, which is the pressure of the gas at STP, to be 760 millimeter mercury. V1 is given as 30.0 dm cube. Then T1 is 0 degrees Celsius at STP. So we'll be converting this to Kelvin, and to do that we'll be adding 0 degrees Celsius will be equal to 0 plus 273, so which is equivalent to 273 Kelvin. So for the final pressure now, P2 is given to be 380 millimeter mercury. V2 remains unknown, while the final temperature is given to be 91 degrees Celsius. So to convert that, we'll be having 91 plus 273, the unit Kelvin, which is equal to 364 Kelvin. Let's proceed. Now we've written out the values given from the question, and the volume, the final volume, remains unknown. So to get V2, we'll be making V2 the subject of the formula. So we have V2 to be equal to P1 V1 multiplied by T2 divided by P2 times T1. So let's substitute the values. Now we have P1 760 millimeter mercury times V1, which is 30.0 dm cube, multiplied by T2 364 kelvins divided by P2 380 millimeter mercury multiplied by T1, which is 273 Kelvin. So this is equal to, we have 8299200 over 103740. Then the unit, since we are dealing with volume, dm cube, and this is equivalent to 80.0 dm cube, which is the final answer. Hence, at 91 degrees Celsius and 380 millimeter mercury, the gas will occupy 80.0 dm cube. And that answers the question.